In this video, we present solutions to homework number 4. In problems 1 through 4, we'll be calculating the slope of the line at point P. Let's go ahead and get started with number 1. To calculate the slope of a line, we simply need to do the rise over the run between any 2 points. So I'm going to choose 2 points that are actually on the grid lines, because it's easier to count the rise over the run. Now the run is the amount over you go to get to the next point, and the rise is how much either up or down you go to get to the next point. So the slope should be, which I'll call m since typically we use that for slope, the rise, which is negative 1, 2, 3, 4, over the run, which is 1, 2, 3, and I have negative 4/3. And that's our answer. Let's go ahead and move on to number 2. This one's fairly straightforward because there is no rise, so the slope will be 0 for rise, and the run doesn't matter since there's a 0 for the rise, and we get a slope of 0. Moving on to the next one. In fact, here you notice any horizontal line is going to have slope 0. So there's really no need to go through this. All right, moving on to number 3. Once again, let's go ahead and look for 2 points on the grid line, and here we have many options. And I'm going to pick these two because they're right next to each other. So the run is here, which is 1, and the rise is here, which is 1. So our slope is 1 over 1, which equals 1. Moving on to number 4. Once again, choose any 2 points. I'm going to go ahead and choose the endpoints of the segment here and compute the rise over the run. Here's the run. Here's the rise. So our slope will be 2 for the rise over 2 for the run, which equals 1. And that takes us through question 4. All right, let's move on. In problems 5 through 10, we need to assign each one of these statements to the points here. In order to analyze the slope of a point, we need to analyze the slope of the tangent line, because the definition of the slope of a point is the slope of the tangent line at that point. So what we need to do is go ahead and draw in a few of the slopes of the tangent lines at these points. This way, we can answer the questions. So let's go ahead and do that. Go ahead and start with position A. Going ahead and drawing that in. We have a tangent line there. For B, we have a tangent line there. For C, there's our tangent line. For D, for E, and for F. And so let's go ahead and look at these. For C and E, it's clear we have a slope of 0, so we can go ahead and label that. For E and C. For A and B, we both have positive slopes, but A is a small positive slope, while B is a steep or large positive slope. So positive slope. And then we have the large one, which is B. And we have the small one, which is A. And then we can look at our next ones. We have F and D, which are both negative. And F is less steep than D, so D will be our large negative, and F will be our small negative. So we have negative slopes. We have large for D and small for F. And that takes us through this problem. For problems 2, 6, 8, 12, and 16, we'll be using Rule 1, Rule 2, and the power rule to take the derivatives of the given functions. Rule 1 says the derivative of a linear function is the slope of the linear function. Rule 2 says the derivative of a constant function is 0, and the power rule says that if we have a power function x to the r, where r is a constant, then the derivative of that function is r times x to the r minus 1. All right, let's go ahead and get started with number 2. All right, notice that this is a linear function with a slope of negative 2, so Rule 1 applies. The slope of this function is negative 2, so f prime of x is just negative 2. For number 6, we have a power function, x to the negative 2. The power is negative 2, so we can simply follow this rule, which gives us that f prime of x is, now bring the negative 2 power down in front of the x, and then subtract 1 from the negative 2. So negative 2 minus 1 is negative 3. All right, moving on to the next one, number 8. We have that 8 is once again a power function, x to the negative 1/2, so we can simply make use of the power rule. So f prime of x is equal to, bring down the power, negative 1/2, x to the 1/2 minus 1, which is minus 3/2. And we're ready to move on to the next one. Number 12. Now I think it's nice when dealing with radicals, especially when taking derivatives, to change the radicals into rational exponents, because then you can use the power rule. So here f of x actually equals x to the negative 1/5. Remember, it's in the power, this 5 means it's x to the 1/5, and it's in the denominator, so we can bring it up, making it x to the negative 1/5. So then we have that this equals, taking the derivative, we can bring down the power, 1/5 x, and now we have negative 1/5 minus 1, which is negative 6/5. And we have our answer. So remember, when dealing with radicals, change them to power or rational power so you can use the power rule. Let's go ahead and move on to the next one. Okay, so this one looks way more complicated than it is. This is f of x equals pi. Remember, pi is a constant, so we're really dealing with rule number 2. So this is about as easy as it gets. The derivative of a constant function is just 0. It doesn't even matter what the constant is. And we're done with these problems. In problems 19 and 24, we're going to be taking the derivative of the function and evaluating it at a given point. All right, since we're going to be taking derivatives, let's go ahead and write down the derivative rules so we have them present and ready to use. And let's go ahead and get started with number 19. All right, we're trying to take the derivative of this function here, f of x equals 1 over x. And remember that it's easiest to change a function like this into a power, bringing the denominator up so that we can use the power rule. So what we have here is really f of x equals x to the negative 1. We want to make use of the rules we have, and the power rule is very useful, so we can convert this into a situation where we can use the power rule. Then we can go ahead and take the derivative of that, giving us f prime of x equals minus 1 x to the minus 2. I just applied the power rule. bringing the r down, and subtracting 1 power. Okay, let's go ahead and evaluate it at a point now. So we have f prime of 2/3 equals negative 2/3 to the negative 2. We can clean this up a little bit. Getting rid of the negative power flips the fraction, and we can even go farther, giving us negative 9/4. And that's our answer. All right, let's go ahead and look back at number 24. Okay. So let's look at this. We notice that this has a radical. Radicals can change to powers, and then we can use the power rule. So let's go ahead and rewrite this as f of x equals 1 over x to the 2/5. And let's bring that up to the numerator so that we can actually apply the power rule. And we have x to the negative 2/5. So then f prime of x is negative 2/5. Bring the power down. X to the negative 2/5 minus 1, so that's negative 7/5. All right, now all we have to do is evaluate this at the point 32. So plugging in 32 into the function, we get negative 2/3 times 32 to the negative 7/5. Now all we have to do is recognize that 32 is 2 to the 5th, and we end up with negative 2/3, 2 to the 5th, to the negative 7/5, which cleans up nicely. The 5 and the 1 over 5 cancel to give us 2 to the negative 7, which is 1 over 128. And this cleans up to be negative 1 over 320. And we have our answer. So just simply applying these rules and then using a little algebra, we can get to the answer. In problem 37, we want to find the actual equation to the tangent line. So when doing a problem like this, it's important to remember that since we're finding the equation of a line, it's nice to start with the formula for a line in either point-slope form or slope-intercept form. So point-slope or slope-intercept form or point-slope form. And let me change this to a 1. Okay, so we need to find the equation of a line, which means we just need to fill in a y1 and an x1 and an m, or we can do it here also. I prefer to use point-slope form, so I'm going to go ahead and fill in this equation here, which means I need to find the slope of the tangent line at a given point and the point. So let's go ahead and first start by finding the slope of the tangent line at a point. So we have a curve here, and we have a point we want to find the slope of the tangent line at. If it helps to have a picture, we have our curve, f of x, and we have a value here, x equals 1/9. And I want to find the equation of the tangent line at this point. That is, I want to find the equation of this line here. So I'm going to need to know this point and the slope of the line. Well, the slope of the line is pretty easy to find, since the slope of a tangent line at a point is given by taking the derivative and plugging in the value of the point. So let's go ahead and start by finding f prime of x. And since we have a radical, it makes sense to change it into a fractional power. And we get f prime of x equals 1/2 x to the minus 1/2. And now we simply need to evaluate it at the value 1/9 to find the slope. And we get 1/2 times 1/9 to the negative 1/2, which gives us 1/2 times 9 to the 1/2, which equals 1/2 times 3, which is 3/2. So what we've done is found the slope of the tangent line at the given point. Specifically, we found the slope of the blue line here. So we found the m value. So we have that m equals 3/2. Now all we need to do is find a point on the line. Well, we're guaranteed of only one point on the line, specifically this blue dot here. Now that blue dot corresponds to an x value of 1/9, but we just simply have to find the y value that corresponds to it. So the y value that corresponds to this point here is what we get when we plug in the value 1/9 to the function. So next we need to evaluate f of 1/9 to get the y value of the point on the line. And we're looking at square root of 1/9, which equals 1/3. All right, so the point that we're going to use is the point 1/9, 1/3. This is the point on the line. Specifically, it's the point on the tangent line. So putting these things together with our formula, we should get the formula for the slope of the tangent line. So we have y minus y1, which is 1/3, equals m, which is 3/2, times x minus x1, which is 1/9. And now we're done with this problem and done with this homework.